Now we have to express these integer as a product of its prime. What are the prime numbers? Prime numbers are those numbers which can only be divided by themselves or 1. That means if you take 6, this is not a prime number because it can be divided by 2, you get 3. 6 can be divided by 3, you get 2. But 5 is a prime number. You cannot divide any number, you cannot find any number which can divide 5. Only 1 or 5 itself. If you divide it by 1, you get 5. If you divide it by 5, you get 1. So these are prime factors or prime numbers. So let us take one of the examples, say 468 we are taking. So these solutions are there for you, but 468, let us take it. 468, we will only use the prime numbers. So let us start with the 2. 2 is the smallest prime number. 2. 2 2s are 4. 2 3s are 6. 2 4s are 8. 2 1s are 2. 2 1s are 2. 2 7s are 40. Now let us take 3. 3 3s are 9 and 27. 3 9s are 27. Now let us take 3. 3 1s are 3. 3 3s are 9. So it becomes 2 into 2 into 3 into 3 into 13. So 2 into 2 into 3 into 3 into 13. This is the prime factors. Determine the prime factorization of each of the following positive integer. So in this case also we have to find the prime factors. These are the prime factors. Prime factors are what? Prime numbers are what? The numbers which are divided only by itself or by 1. So let us take this example. 58500. Let us start with 5. 5 1s are 5. 5 1s are 5. Now 35. 3 remains 35. 5 7s are 35. 0 0. Let us take 5 again. 5 2s are 10. Now you get 17. So 5 3s are 15. 20. 5 4s are 20. 0. Again let us take 5. 5 4s are 20. 34. 5 6 are 30. 40. 5 8s are 40. Now 468, because we have already done that, so let us utilize this. 2 into 2 into 3 into 3 into 13. So this will be 5 into 5 into 5, then 2, 2, 3, 3 and 13. This we have already done, okay? That is why I am just taking from the previous question. What will be the prime factorization? 5 into 5 into 5, 2 into 2 into 3 into 3 into 13. So this is the prime factorization. Explain why this number and this number, which is actually an expression, these are composite numbers. So composite numbers, for example, 5 is not a composite number, but 6 is a composite number. How? 6 can be written as 2 into 3. So it has factors other than 1. So any number which has factor other than 1, for example, 5 is 5 into 1, but 6 is 2 into 3. If you take any number like 9, it will be 3 into 3. So 9 is a composite number. So how these two numbers are composite number? This is 7 into 11 into 13 plus 13. So let us take 13 outside. So what do we get? We get 7 into 11 inside. So that is 77. If you take 13 from here, you get 1. So this is 13 into 78. So it's a multiplication of two numbers. So it's a composite number. Similarly, with the case of this, here we see 5 is the number which is common. So let us take 5 outside. 5 we are taking outside. Inside this will be 7 into 6 into 4 into 3 into 2 into 1, which is here. And when you take outside 5, you get 1. And when you actually multiply these, you will get 1007, add 1, that is 1008 into 5. So this is also a form of m into n, right? Where m and n are not equal to 1. Because the composite numbers are those numbers which have at least one more factor than other than which is 1. Check whether 6 to the power n can end with a digit 0 for any natural number n. So any number which ends with 0, that means say 50. 50 has come from 5 into 10, right? And 10 is what? 5 into 5 into 2. So you ought to have this 5 into 2. If 5 and 2 comes in any way in this 6 to the power n, then we can say that the multiplication, that is 6 to the power 1, 6 to the power 2 or any 6 to the power n number will be ending with 0. So you ought to have 5 and 2. That is, we want to check for 0 in the end. So 6 to the power n can be written as 2 into 3. 6 is 2 into 3. Let us take power n. So a into b to the power n is a to the power n, b to the power n. You see, the prime factorization of 6 to the power n does not contain 5 and 2, right? Factored together, because we need 5 and 2 together, because 5 into 2 will give you 10. So 6 to the power n can never end with a 0 for any natural number n. So these